Here is another example of an SR latch. Now, in this case, I connected the enable switch to a computer clock, and you can see the clock going on and off and on and off. And if I open up the oscilloscope, we can take a look at the wave, and you can see that it's going between 5 volts, 0 volts, 5 volts, 0 volts, or logic 1, logic 0. This is a pretty slow clock. In reality, your computer has a clock speed measured in megahertz, that's millions of cycles per second, or gigahertz, billions of cycles per second. But everything in your computer is run off a clock, and this helps keep things in sync. And in my little example here, you can see that I've connected the clock to my enable, and I can only set or reset my memory when the clock is at logic 1, represented by this little light being on. So let me try to set this thing, and if I set it, now notice there's a delay, and as soon as the clock goes to 1, my memory got set, and now I'm back in memory state. I can reset, but again, nothing happens until the clock went up. Now I'm back in memory state. Remember, this is nothing new. This is your SR latch. I've just connected the enable to a clock, and it just keeps everything in sync. So again, I can set. Nothing happens until the clock goes to a logic 1. I can reset. Nothing happens until a clock goes to logic 1. And here I am back in memory state. And your computer, of course, again, has a much faster clock speed, but it's necessary. Everything is run off this clock in order to keep memory and all instructions in your computer happening at the same time, keeping everything in sync.